Welcome back. We're going to do one more today. If you hear something in the background, it's not at your house. My neighbor is having the leaves blown, which I hate. But that's beside the point. We're not going to let it affect our enjoyment of gravimetric analysis. So we've done two already, so we should be getting a little bit more familiar with the process. So I'm going to read the problem, and then this one has a couple of little interesting things in it. So it's good, to do multiple problems. Don't just do one and think, oh, I'm done and I understand now. A 50 milliliter unknown aqueous sample was tested in the laboratory. The unknown sample was identified to be lead-2 ions by a precipitation reaction with sodium iodide. Since the unknown was identified to have lead-2 ions in it, a student added excess sodium chloride to the 50 milliliter sample. A white precipitate was made and subsequently filtered, washed, and dried to completion. The precipitate was measured to have a mass of 2.350 grams. Okay, so what I'm seeing here is I've got 50.0, that's 3 sig figs. I've got 4 sig figs from my mass. They're using one of those really nice analytical balances that go out to the thousandths place. And if you don't think saying thousandths on a video is hard, try it a couple times. So we've made a precipitate. We want to know how much lead is in that precipitate. And, the reason we're usually interested in lead is because it's toxic, and it used to be in a lot of different things, in pipes, in white paint, lead oxide, and, it does have kind of a sweet taste to it. And that's... people when I was younger would, because that was when, they first figured out really a lot about the lead paint and stuff, and people would, kind of make a joke, even though it was pretty awful, and it was usually, babies that were eating the paint, but, the thing was, who would eat paint? But if you wouldn't eat it if it didn't taste good. And so, that's kind of the thing with lead and lead compounds. Now, I've never had it myself, but, the rumor is that they taste sweet. I would not recommend you trying it out. But we often in chemistry are looking for lead and lead compounds, because lead compounds are also really easy to make precipitates with, because lead, you put it with a chloride, boom, you got a precipitate. About the only thing that lead doesn't precipitate with is lead nitrate. So a lot of times in a gravimetric problem involving lead, you're going to start out with lead nitrate and then make like a lead chloride precipitate. So I'm just going to go down through here to do A through E. How do the students determine, through the addition of sodium iodide, that lead had the sample had lead-2 ions in it? Got a little ahead of myself there. And this one, I had to think about. And I don't know, I think maybe, there was more to this problem on a previous worksheet or something, because this isn't the kind of thing I would expect you to know, and more importantly, I don't think it's this kind of thing that College Board expects you to know, is that there is no form of lead-4 iodide. So lead, because it has 4 valence electrons, when you look at it on the periodic table, it had, it's in that carbon group. It has 4 valence electrons. And the thing is that tin and lead are far enough down in the family that those valence electrons are far enough out that they're going to behave like metals, okay? And so as they're behaving like metals, they're going to lose electrons, but they will lose either the 2 in the P and become +2, or they'll lose the 2 in the P and the 2 in the S and become +4. Now, certain compounds exist, other compounds don't exist. And so that's why the student mixes first with the sodium iodide, because if a compound doesn't form, then we know that there's lead 4, and we need to, be adjusting and thinking about, what's something that we could use to precipitate some lead 4. But once we know that, a precipitate forms with the sodium iodide, that would indicate, since sodium iodide does exist, or lead 2 iodide does exist, we can safely assume that we have lead 2. Now, to be perfectly honest, I don't know why the student switched to sodium chloride, other than sodium chloride's extremely cheap, and we usually have more sodium chloride sitting around the lab than we would sodium iodide. So maybe it was a cost issue. But the short answer to A is the student first used sodium iodide because lead 4 iodide is known not to exist. When a precipitate form, the lead could be identified as existing in its +2 form. And those, you don't need to write a book, but those 2 sentences will get you where you need to go. So let's look at B here. Write the balance net ionic chemical reaction for the unknown sample and the sodium chloride. So when I'm looking at that, it's just like normal. Now, the only thing is, I don't have any other thing to pair with the lead, so I just put the lead in there and kind of wrote it like a single replacement reaction, because I know that the sodium and the chloride bust up. And then if I'm making lead 2 chloride, I'm going to need 2 chlorides. So I put a 2 in front of the chloride, and I put a 2 in front of the sodium, because you need to have a balanced equation. And in order to make, you can't just PbCl, okay? That's not, it would have a +1 charge, and that precipitate can't have a charge. And so that's why it's important that we put the correct formula and we also balance that equation. So I've got my Pb +2, 2Cl negatives, PbCl2. All right, so calculate the moles of the precipitate. And so when the first thing I need to do is add up the molar mass of the lead 2 chloride. It's a bad habit when I say PbCl2. Nobody talks about it that way. It's lead 2 chloride. So I add that up, and you see how I did that there. There's lead 207.2, 2 times 35.453 for the chloride, and so that adds up there. And then I have that, put it there, and it's just, simple stoichiometry. But again, it's important to show it because this is the evidence that we're going to show on our AP exam that we do know what's going on. And so, since I started here with 4 sig figs, I keep my 4 sig figs and I write it in scientific notation, so it indicates that I'm keeping those 4 sig figs. Determine the moles of lead 2 ions that are present in the unknown solution. And so, again, that's real easy, but we have to show our work. And I'm trying to get on my work here. And so if I have that much lead 2 chloride, I know that I have 1 mole of lead in 1 mole of lead 2 chloride. And so it's all ones. We know what the answer is going to be, but that evidence is important. And if you just wrote the number down again with the PB plus 2 after it, that's not enough to get you credit for showing your work on the AP exam. You actually need to set it up with that ratio. And then E, calculate the concentration in molarity of the lead 2 ions in the unknown solution. So in this way, it's pretty easy. We have that 8.450 times 10 to the negative 3. And all you need to do is you take your 8.450 times 10 to the negative 3, and then I take this, it's got 3 sig figs, which I just divide it by 1,000, and so 50 milliliters is 0.05 liters, get a look there, and for some reason I did not solve that till right now, so I'm just going to plug that in, 0.00845 divided by and it's actually really convenient when you take it out. It gives you 0.169 molar, and because of that 50.0 volume measurement, you're going to want 3 sig figs anyway, so 0.169 molar, and boom, there you go. That's it. That's all you need, and that's a wrap.